Welcome to the second of 7 videos covering quadratic theory at higher maths. This video is going to focus on completing the square. Some of what I cover will be a recap of the National 5 level of work, and some of it will be extension into what is considered higher level, completing the square. So, first learning intention. I want to do a recap on the basic completing the square method. This should be rather short because hopefully most of you are quite comfortable with the process. So completing the square for unitary x squared terms. So the standard definition of quadratic, as you all know, is y equals ax squared plus bx plus c. However, we can turn the standard form into completing the square, which is y equals bracket x plus p bracket squared plus q. In this form, we already learned in the recap in video 1 that we are able to read the turning point from the quadratic equation in its graphical form. This will be more useful as we move into higher because we're actually going to have some uses that are kind of higher level uses for it, which we'll cover in subsequent videos. So complete the square for y equals x squared minus 4x plus 13. Have a go. So the method for completing the square. You look at the first two terms, the x squared term and the x term, and what you do is you take those, you put them in a bracket, and you remove the square term, half the coefficient in front of the x, remove the x, and put that all in a bracket squared. Now, if you multiply that out, what you'll get, x minus 2 squared, is just multiplied out, gives you x squared minus 4x plus 4. It creates the same x squared minus 4x, which is what we want, which is what we had above. But in doing this process, we've created an add 4 that we want rid of. We have to get rid of that. So to undo a plus 4, we do the opposite and we take away 4. That allows us to simplify the minus 4 than the plus 13 to give us bracket x minus 2 all squared plus 9. That's you completing the square for the equation y equals x squared minus 4x plus 13. Some more examples to try. Example 2 is taken from a past paper. I think National 5 past paper, but it could have been credit or intermediate 2, but I'm pretty sure completing the square was only in National 5. So again, look at the x squared and the minus 14x. We drop the square, half the coefficient in front of the x, and get rid of the x, and I'll put that in a bracket squared, which when you then combine that the bracket squared is going to give us minus 49, we've got to take away that 49, we've still got to add our 44, which comes from above. Simplifying gives us bracket x minus 7, close bracket, all squared, minus 5. This example here, I've thrown this example in for example 3 deliberately, because when you half the coefficient of 3, you don't get a whole number, you get a fraction or a decimal, depending on whatever one you want to use. I advise using fractions again. At higher, it's more useful, but you don't have to. So drop the squared, half the 3, get rid of the x, put it in a bracket squared. That leads us to the bracket being x minus 3 over 2, close bracket squared. We still got the plus 1, so we're going to have to undo. Sometimes it might be worth doing the sum at the side. It turns out it's the minus 3 over 2 squaring itself is what we're going to have to deal with. And at the end, that turns out we're going to have to deal with a plus 9 over 4. To undo a plus 9 over 4, we need to subtract 9 over 4. Okay, so we might subtract 9 over 4. We then have to simplify that with plus 1. So as mentioned before, your fraction skills have to be comfortable because you're now having to add a fraction with a whole number. And you have to deal with that successfully. Again, you don't have to show every line of working. Some people get to a point where they're very good with fractions and can do all of that work in their head. So this second level doesn't need to be shown. And you could just jump straight to x minus 3 over 2 squared minus 5 over 4. Now, learning intention. The higher level skills for completing the square are being able to complete the square for quadratics with non-unitary x squared terms. Basically what that means is what was it? Any x squared term. So you could have 2x squared, 3x squared, 4x squared, 5x squared. So it's not limited to just x squared, which is what you learned in National 5. So to complete the square for the following quadratic and state the turning point of the equation, y equals 4x squared plus 8x plus 3. Feel free at this point to pause it, have a go yourself, see if you think you've got a way of doing it. Otherwise, just watch on and I will show you how. So step 1. Remove as a factor the coefficient of the x squared term, which in our case is 4, from both the 4x squared and the 8x. So you're basically removing whatever coefficient is in front of the x squared, you're removing that from both the x squared term and the x term. It must be both. to give a unitary x squared term. Once you've done that, you're then allowed to deal with the x squared plus 2x as you've dealt with previously. So it becomes the similar method, but there is a quirk at the end we need to pay attention to. So get rid of the square, half the 2, drop the x and put in a bracket squared. Don't forget the 4 is still there when you write it. We've got the plus 3. Now, this is the interesting part. When you multiply out 4 bracket x plus 1 all squared, what you end up with, okay, is x squared plus 2x plus 1 in a bracket with a multiplier of 4 outside. Normally in the past, if we didn't have that 4, we would have had to deal with a plus 1, but we're not dealing with a plus 1 here. We're dealing with a plus 1 that will be multiplied by 4. So we are dealing with plus 4. So it has to be undone, is not plus 1. We don't have to undo plus 1. We have to undo plus 4. So watch out for that. This extra bit is the wee quirk for, kind of higher level completing the square that you just have to pay attention to. So here, we're going to subtract 4, not 1. After that, simplify the minus 4 and the plus 3, write out your full, 4 bracket x plus 1, close bracket all squared minus 1. So again, the process is not massively different for completing the square. You just need to remember to remove that coefficient. And also pay attention, this question did ask us to state the turning point. As I've said before, completing the square allows us to find the turning point very straightforward. So in this one, our turning point is simply minus 1, minus 1. There's nothing else you need to do here. The 4 does not affect what the turning point is, as long as you took the correct coefficient out at the beginning in front of the x squared term. Second example, this is actually taken from an older past 2006 higher paper 1 question 8. So feel free to have a go at both A and B. Part A, relatively straightforward. It's just completing the square at higher level, watching out for the coefficient. So we take the 2x squared plus 4x minus 3, and we take the common factor of 2 out. That leaves x squared plus 2x in the bracket. Remember, we take the common factor out of the x term as well, but not the minus 3. At this point, deal with the x squared plus 2x. So we drop the squared, half the 2, drop the x and put it in a bracket squared. Again, we need to take care with what comes out, but hopefully you don't have to do multiplication out. If you understand that plus 1 squared would have given you 1, times that by 2, we would have a positive 2 we need to deal with. So we subtract 2, and then we take away the 3. But if you want to do the extra at the side, feel free to do it again. Able mathematicians start doing things kind of, automatically and don't have to do the same level of working. But again, in your exam, if you need it for confidence, feel free to do the extra work. Just you might not have the time to complete everything else. Finally, just simplify the minus 2 and the minus 3. Watch out for any negatives. They, again, tend to be the big problem makers for most pupils. So then you get 2 bracket x plus 1, close bracket squared minus 5. So once you've done all of that, you've completed the square and therefore gained your 3 marks. Now, again, I'm not convinced at higher that you would gain 3 marks for completing the square, even the harder example. Given that completing the square is now part of the National 5 curriculum, I don't think they would be as generous, because certainly part of it is a skill you've learned previously, whereas in the higher in 2006, it was a completely new skill, completing the square. But that's not to say they wouldn't give you 3 if it did come up. Now, part B, write down the coordinates of the turning point of the parabola with equation. Again, I've warned you before, if it says the words write down, that's basically telling you should be able to do this with little to no working. And that is the case because completing the square allows us to find the turning point. And the turning point in this case is therefore minus 1. Remember, it's always opposite in sign inside the bracket for the x term of the coordinate. So it's minus 1, minus 5. That's it, 4 marks, quite straightforward. Third example. Right, so complete the square for y equals 2x squared minus 3x plus 5 and state the turning point of the equation. Again, take the common factor of 2. I've chosen this one just to show you that that may not lead to a nice common factor and nice coefficient in front of the x once you do remove it. So taking 2 leaves a fractional coefficient in front of the x, which you're going to have to deal with. Again, warned you before, being able to deal with fractions is important at higher. Again, process the same, drop the squared, half the coefficient in front of the x, put it in a bracket squared. So we're going to get 2 bracket x minus 3 over 4, because if you half 3 over 2, you get 3 over 4, all squared. Again, that means you're going to square 3 over 4, and 3 over 4 squared is 9/16. That's going to be times by 2, which is going to give us, I think, 18 16ths. Again, if you want to do this off to the side, feel free. I get to the point that I understand it's just 3 over 4 squared is the bit we need to deal with, so that's why I'm doing 3 over 4 squared and then timesing it by the 2, simplifying the maths there, I'm going to get 9/8. So I'm taking away 9/8. That means I've got to add the 5 to the 9/8, dealing with the fractions. Feel free, you don't have to add the step where you've got the 40 over 8 in there. You can do it in your head if you're at that point. If you're not, feel free to write it. And then complete the square. So you should have got 2 bracket x minus 3 over 4 all squared plus 31 over 8. At this point, we've been asked to state the turning point in the core of the equation. Just read it off. It's going to be 3 over 4, signs change, and 31 over 8 for the y coordinate. Again, this is me just trying to show different types of examples, so have a go at this one. Hopefully what you'll notice is different is it's not been written in the correct order for standard form. So my advice, first step, is rearrange into that form. And don't forget the negatives when you do this. This has got a negative x squared term. This is important and it's going to be relevant because this is one that has a tendency to catch pupils out when they do it. So common factor, the coefficient here is actually -1. So you take -1 out, you don't have to write the one part out, just write the negative outside the bracket, then follow the same process, drop the squared, half the 2, drop the x, and put it in a bracket squared, which gives us this. Now, this is the interesting part. When you multiply out minus bracket x plus 1 all squared, that negative is going to change the +1 to -1. That means, okay, when we go to remove it, we're not actually going to be removing by subtraction. Normally, we always remove by subtraction because the square will always give a positive answer. But because we've taken a negative outside of the brackets, a coefficient at the beginning, that's going to turn that positive negative, which means we're going to have to remove a -1. And to do that, we have to do it by addition. So there are scenarios in completing the square where you'll remove the bit you don't want by addition, not subtraction. You just have to pay attention. And that will normally always occur when the x squared term is negative. So we're going to add 1 to both terms. We're going to get +1 plus 3, which simplifies to minus x plus 1 all squared plus 4. Obviously, that has quite a big impact on what your y value of your turning point will be. So just pay attention to that type of example because it does have a tendency to catch pupils out. And be aware, the answer could be written, and sometimes written at the back of answer booklets, it's 4 minus bracket x plus 1 close bracket all squared. And in that sort of scenario, either or is acceptable. So just be prepared. If you're doing work from a textbook or from a past paper, don't think that's wrong. That is indeed as correct as the one above.